Okay, let's talk about the inverse sine function. I've written a few notes here that we can go through to briefly summarize the graph of sine and how we come up with the arc sine or the inverse sine. So let's see. First we have the notation. Sine inverse is written as sine to the negative 1, but it also can be called arc sine. They're the same thing. Please don't make the mistake that sine to the negative 1 right here is not the same as 1 over sine. Okay, sine to the negative 1 is just a way of writing this is the inverse. It's not actually to the negative 1 power, so don't get those mixed up. And then we've learned that from earlier sections that in order to have an inverse, a function must be 1 to 1, which means it must pass the horizontal line test. If you notice, in this function of sine, if we draw horizontal lines, it does not pass the test. It crosses many more than one time. So this is not 1 to 1, and that means the graph of sine does not have an inverse. Now we do want to look and try to find an inverse sine function. So what we need to do is we can restrict the domain. So if I restricted it between negative pi over 2 and positive pi over 2, leaving everything else out, let's just restrict it between those two values. If you notice, we now have a function in between these two that do pass the horizontal line test. It only passes one time. So now we can find the inverse sine function as long as my domain of sine is restricted to make it a 1 to 1. So for this sine, we've restricted the domain to, let's see, negative pi over 2 to positive pi over 2. That's the domain. And my range, let's see, it goes from negative 1 to 1. This is for my restricted domain of sine. Now if we look at our inverse function, if you remember for inverse functions, you basically switch your domain and your range. So for the inverse sine, the domain would be negative 1 to 1, and the range would go from negative pi over 2 to positive pi over 2, which are my angles. Now keep in mind that sine to the negative 1 is the same thing as the arc sine of y. Both of these represent the same thing, and your answer for those should be some value of theta, some angle. And we know that our range for arc sine will go somewhere between negative pi over 2 and pi over 2. So if we like to think of it in terms of the unit circle, let's see, we have 0 here, pi over 2 up here, and negative pi over 2 would be starting at 0 going in the negative direction. So basically, our answers lie somewhere in quadrant 1 or quadrant 4. For this case, angles that lie in quadrant 1 will be our reference angles, our positive reference angles, and angles that lie in quadrant 4 will be negative reference angles. For example, this would be like negative pi over 4 or negative pi over 3. Okay, let's look at some examples. Number 1, the inverse sine of 1/2 equals what? Okay, so remember when you're looking for the inverse sine, your answer should be some kind of angle, some theta. Now we can rewrite the inverse sine as sine of theta equals 1/2. So we are looking for what angle gives us the sine equals to 1/2 and positive 1/2. So we can look at our chart over here, my handy chart that I like to use for my reference angles. Where is the sine 1/2? So the sine is 1/2 at pi over 6 or 30 degrees. So in this case, my theta is pi over 6. So notice my sine produced a positive, and now we know for our all students take calculus, right? Sine is positive in the first quadrant and negative in the fourth, right? And for inverse sine, we're only restricted to quadrant 1 and quadrant 4. We don't do any of these. Okay, so basically, if your theta produced a positive sign, you know it's quadrant 1. If it produced a negative sign, you know it's quadrant 4. Okay, example 2 is very similar to example 1, except this time I'm asking for the inverse sine of negative 1/2 equals theta. So we can rewrite it and think about it in terms of the sine of theta equals negative 1/2. What theta gives me negative 1/2? Remember, as I told you before, you're either going to have an angle in quadrant 1 or in quadrant 4. The angles that are in quadrant 4 produce negative trig values. So since we have a negative right there, negative, that means we are in quadrant 4. It's very easy to remember because we're just going to check it again. When is sine 1/2? So up here in this our little chart, sine is 1/2 at pi over 6. So our theta is pi over 6. But since it produced negative 1/2, we know it's quadrant 4, which means my angle would be negative pi over 6. Now think about it. For quadrant 4, if we have this angle right here, we're used to writing it as, let's see, 11 pi over 6, but since we're restricting simply between negative pi over 2 and positive pi over 2, we'll write that as negative pi over 6. That's my answer. Okay, let's look at example 3. We have the arc sine of negative square root of 2 over 2. So if we rewrite that, we have the sine of theta equals negative square root of 2 over 2. So we basically just go up and check where sine square root of 2 over 2. That happens at pi over 4. So we know my theta is, my reference angle is pi over 4. It's just easy to remember. Since we produced a negative, we just put a negative on my angle. Negative pi over 4. Okay, now since we're talking about sine and arc sine, we know that sine and cosecant are reciprocals of each other. So in this case, number 4, we're asking for the inverse cosecant. So we want to write it in terms of sine first and solve it there. So if the inverse, let's see, if we have cosecant of what theta equals 2 over the square root of 3, let's rewrite that. That's the same thing as saying the sine of theta equals, and remember it's the reciprocal, square root of 3 over 2. So change it first in terms of sine, and then we can solve it. So we look over here, the sine of theta. Where is it square root of 3 over 2? Square root of 3 over 2. Sine is at pi over 3. My theta is pi over 3. Remember, since we had a positive value, we know my angle is positive. And finally, number 5, the arc cosecant of negative 1 equals what? We need to know what angle that is, so let's rewrite it. That's the same thing as saying the cosecant of theta equals negative 1. Okay, but let's rewrite cosecant as the sine of theta, and we're going to flip negative 1. So if we take the reciprocal of negative 1, we still get negative 1. So where is the sine of theta negative 1? So we come over here. Where's the sine 1? Right here. That happens at pi over 2. But since it was negative 1, we put a negative on it. Right here, the negatives just carry. So if you have a negative value, your angle is negative.